Hi, in this lecture we are going to continue with cross-site scripting, but we'll talk about stored cross-site scripting. So the difference between reflected and stored cross-site scripting is that in case of a reflected, the malicious input is not stored on the server, but it's immediately sent back to the browser. However, with the stored cross-site scripting, surprise, surprise, the data is stored in the application database, and then it gets shown on various pages of the application. So basically, in case of a stored cross-site scripting, the attacker can deliver the malicious input himself and then wait until the target user or any users load the page where the malicious input is used, and all these users will be automatically tagged. So let's start to look at the other applications we know. So as before, go to the console of the Etherlab target machine and look for the Imperial Intelligence URL. Here's the URL. It's the same as the Voice of the Emperor, just with II at the end for Imperial Intelligence. Now load the URL in the browser, II, and you could do the same discovery what we did with the other application. It's a person of interest application, so basically a database about various people who are, for some reason, are interesting for the Galactic Empire.
The shield must be deactivated if any attack is to be attempted.
If you open any of the profiles, I go with Luke Skywalker, then you see that at the end there's a comment section. So we're going to experiment with the comment, whether it's vulnerable to stored cross-site scripting. You see, our input with the comment will be stored in the database and then shown to every user who opens the profile of Luke Skywalker. So first of all, I will just test comment. What I usually do is I use the following test string, because this contains various special characters which could affect cross-site scripting. So if you submit this and then in the website where this string is used, then you might see something weird. And if you see something weird, then it makes sense to investigate further. So you can fill out the user and the email address, but it's not necessary, and post comment. And you could see that it is weird. The XSS tag is missing. Let's see a little bit closer. So open the developer tools inspector. With the inspector, you can just easier inspect the HTML code. It's good if you have a bigger page. So yes, that's exactly what we were expecting. So you could see here's the first part of the test string. And then when the XSS tag comes, the browser really thought that this is a tag called XSS, an HTML tag. And then comes the second part of the string. And because there was no ending for this tag in the string, the browser added one. So this really looks like cross-site scripting, because the browser interpreted our input as HTML. All right, then let's do another test with probably the most famous cross-site scripting test string ever, alert 42. Yeah. So with that, we are trying to execute a JavaScript in the comment and make a alert window. Let's post the comment. It didn't work, and it says that the Imperial Cyber Counterattack team is notified. Yeah, that's bad for us. But anyways, if we are here, just keep testing. It happens many times that the application has some kind of protection against cross-site scripting, but most often there is a way to circumvent this protection. So now our simple script tag didn't work, so we just need another way to exploit this this potential cross-site scripting. The good news is there are more or less unlimited ways to exploit cross-site scripting. What I usually do, you can search for OWASP XSS cheat sheet. Okay, it's because of the burp suite. Actually, I turned this off for a second because it's super slow. And if you open this filter evasion cheat sheet, you will see that the locator, there's a longer locator, and here is the short one which I used. And then there are lots of various ways how you could exploit cross-site scripting. These are all techniques to avoid some kind of filtering or protection mechanism. You see there are a lot with image tag. So that's gonna be the next step what we're gonna try, to include JavaScript with an image tag. For that we say img source is, I will explain what this means in a minute, on error alert bound. It's important that the on-error attribute can contain JavaScript. That means that when some kind of error occurs with the loading of the image, this code will be executed. Now, for this to be executed, we have to trigger some kind of error. And to do that, we are going to load an image from a bogus source. This is this XX. And since that's going to cause an error, the JavaScript in the onError attribute will be called. So let's see if this works. Awesome. So as you can see, it worked. We get the pop-up window with the string. And if you push OK, you could see that there is this image which couldn't be loaded, which is fine because that's what we wanted. You can see it here in the HTML code. And it executed the injected JavaScript. So what this means for us, that anybody who browses this website and opens the profile of Luke Skywalker will get this JavaScript executed. So from here on, you can do whatever you want in the JavaScript. You could try to steal the session cookie, do some kind of manipulation on the website, load like rootkit in the browser, or even try to exploit the browser itself to get access to the user's whole machine. So there are unlimited ways what you can do with cross-site scripting, because the JavaScript in the browser is really powerful, and you will get all this power when you have a cross-site scripting attack. This attack is now much more widespread than the other because everybody will be attacked who opens this page. With the reflected cross-site scripting, we only attacked that user whom we social engineered to submit our malicious link or something like that. But in this case, everybody is attacked who opens this page. Also, if we want to do targeted attack, we can just trick the user to open this page by sending this link to him or something like that. With that, we are finished with cross-site scripting. There are various ways how cross-site scripting can occur in a website. Sometimes you can inject into JavaScript directly, sometimes through file upload, sometimes you can attack through XHTML, sometimes even through CSS style sheets. So there are lots of ways how a cross-site scripting can happen and how you can exploit them. So it's really up to your creativity. But important is to recognize when you can manipulate the website with your user input. If you can manipulate it some way, then you might be able to get it to working exploitation. As an exercise, you can try to find out why the protection against script tags, which gives us this error message, didn't work against the image tag. You can try to look it up in the source code of the application. You find it on the target server under /var/www/html/ii. If you're ready with that, I will see you in the next lecture.